Bismillah. In this video, inshallah, we will solve Unit 7 focused questions with explanation. طيب. A block on a horizontal frictionless plane is attached to a spring as shown above. The block oscillates along the x-axis with simple harmonic motion of amplitude A. Which of the following statements about the block is correct? Now, A, at x equals 0, the velocity is 0. Of course, that is not right. Let's explain the three situations we have here. The velocity will be 0 at the end of the motion, at the edges of the motion, where the velocity is changing the direction. So here at both ends, at the maximum displacement, the velocity equals 0. That means the kinetic energy equal to 0. The potential energy is max, equal to the maximum, right? Same thing here, kinetic energy 0 joules, potential energy max. Now, what about the equilibrium point? When the mass passes through this point, the velocity will be maximum. The kinetic energy will be also maximum. The potential energy will be 0 joules. Of course, that goes with the formulas. If you look at the formulas, you will find that is correct. طيب. So the first option is not right. The second option, x equals 0, its acceleration is maximum. So we didn't talk about the acceleration. Actually, the force is maximum at the ends, because we know that force equal negative kx. So the force is maximum when x equal a. And we know that F equal ma. So the acceleration is maximum when the force is maximum. Then we can say at the ends, acceleration is max. Also, force is max. Acceleration max. Well, force is also max. So, it is not right. C, at x equal a, the displacement is maximum, which is right, yes. We know that. A aslan is the amplitude, which is the maximum displacement. Now, next question, let's go to question number 4. Actually, it is the second in order, but the fourth question in topic 2, 7.2. A simple pendulum consists of a 1 kilogram brass pop on a string about 1 meter long. It has a period of 2 seconds. The pendulum would have a period of 1 second if the... Actually, let's remember the formula for the period in the pendulum. T equal 2 by radical L over G. So how can we reduce the period from 2 to 1? To reduce the period from 2 to 1, actually G is constant since we are in the same planet. So to reduce the period into half, we need to reduce the length into quarter. Why? Because it's a radical L. So the answer is A. The string were replaced by one about 0.25 meter long. Let's look at it again. T equal to pi radical 1 over 4 L, let's call it T dash over G or T prime. Now T prime equal 2 pi over 2 radical L over G. This is T, the period. So the new period is half the old one, which is 1 second. Next question. A simple pendulum has period of 2 seconds for small amplitude oscillations. The length of the pendulum is most nearly, okay, if the period is 2 seconds, now we'll use the same formula, T equal 2 pi radical L over G. Of course, T is the period, we needed 2 seconds, according to the equation. 2 pi multiplied by radical L over 9.8. Using the calculator, you will find that L equal 1 meter. So it's most likely D. So we just used the formula here. Next. Okay. The graphs of position and acceleration as functions of time for an oscillating simple pendulum are shown. The magnitude of the acceleration at time t equal 1 second is most nearly. So, how can we find the maximum or the magnitude of the acceleration at time equal 1? When we look at the formula, we can find that, when they look at the graph, it's clear that after 1 second, the acceleration will be maximum, but in negative sign. So the magnitude is maximum. طيب, here after 1 second, the position also will be maximum. And that also, if you remember what we said before, when x is maximum, the acceleration should be maximum also. And that proved now also again. Okay. Now, to find the maximum acceleration equal a squared multiplied by, a multiplied by omega squared. Now, but what is omega? We know that omega equal 2 pi over period. So what is the period? The period is 4 seconds. If you look at this graph, this is one complete wave. This is the green one. That is 4 seconds. So period equal 4 seconds. W equal 2 pi over 4. That means pi over 2. Now let's substitute this. And yes, we can say that A, the maximum amplitude or the maximum displacement, is 3 centimeter. This is A. Now A is 3 centimeter multiplied by pi over 2 squared. Now, maybe you will ask why we didn't convert 3 into from centimeter to meter. Actually, because we can see here the units used in the options are centimeter. So let's keep it centimeter. Okay, using the calculator, acceleration equal to 7.4 centimeter per second squared. Look at the options and you will find that the answer is B. Next question, number 16. The graph shows the position x as function of time t for an object in one-dimensional simple harmonic motion. Which of the following expressions gives the object's velocity as function of time? As function of time, we know that the velocity is, yes, the velocity as function of time, v equal negative omega a times sine omega t. This is the formula, the main formula we have. Now to find the specific formula for this specific motion, we need to determine W. We need to determine A. Of course, A is 0.4 meter. Done. Omega is 2 pi over period, 2 pi over t. Then 2 pi over, what is the period here? It's also 4, right? Yes. From this point to this point, those are 4 seconds. So 4. Okay, that means pi over 2. Now let's substitute this. We will have that V equal, yes, here we need to be careful that the motion started in negative 0.4. So let's add negative at the amplitude. طبعا for the amplitude, we don't add negative for the amplitude, but when we substitute it in the formula, we add the negative. Now, it will be pi over 2 multiplied by 0.4. Of course, here negative and the original negative, they will cancel each other. Times sine pi over 2 times t. Now, of course, negative with negative will cancel each other. So the answer will be V equal 0.2 multiplied by pi times cosine, times sine pi over 2 times. Now, this is the final answer. Look at the options. We find that the answer is A. Next question. طيب. Which of the following statements about energy is correct? We can طبعا read the question and answer it. The answer will be, as we said before, the potential energy of the spring is minimum at x equals 0. This is right. At x equals 0, the potential energy is minimum. Actually, it's 0. So yes, that's right. And if you look at the other options, all of them will give us wrong answer, as I explained before. Now, next. A mason spring of spring constant K oscillates as shown. Which of the following graphs would you correctly depict the kinetic energy the kinetic energy versus the time for the oscillating mass? Now, as we know, the kinetic energy will be maximum when it's at the equilibrium position. If you remember, let's go back to the graph, to the figure here. The kinetic energy maximum, as you can see, when it's passing through the equilibrium point. Now, let's go back. Here, it starts at equilibrium point. So it will start at the maximum. Here, this is the equilibrium, right? This is the maximum maximum displacement. So at the origin, it would be the equilibrium point. So what is the equilibrium point? It has its maximum kinetic energy. So directly we cancel A, we cancel C because it's not changing, we cancel E because it's minimum at the beginning. But we know that at the beginning it should be kinetic energy should be max, right? So now we stuck with B or D. Now, okay, both are positive, so yes, both can be right. I was looking if there is anyone negative, we can cancel it directly, but there is no negative solutions here. طيب. After one period of time, it should be 0. After one period of time, it is 0 here. Here, it's not 0. So D is wrong and B is right. Why? Because when the kinetic energy at the maximum displacement, kinetic energy should equal to 0. Also, it is mentioned above. Okay, next. This is free response. We need to solve this question. Actually, it is the parts included in the final is only B and C. But to solve them, we need to solve A. So, to solve A, طيب, I will make another video for the free response just to make videos